Hi, this is Jeff Hamrick at the University of San Francisco's Financial Analysis Program. I'm going to talk for a couple of minutes about the link test in Stata, which is one test that we can use to see if the equation that we have created connecting a dependent variable with some collection of independent variables, whether or not it might suffer from a misspecification problem. That is, whether or not the wrong forms of the independent or dependent variables have been used, or whether or not some additional independent variables that we have not initially included in our analysis should have been used. So I'm going to use a set of data that has been installed with Stata. It's called the automobile data set. I'll use the command sysuseauto to bring it up. And let's imagine that I would like to predict miles per gallon using some variables that very sensibly would seem to be related to miles per gallon, like weight, displacement, and the indicator variable as to whether or not the car is a foreign or US car. So when I execute this equation, I see that it appears to be a decent model. Weight is the significant variable. The others, displacement and foreign, do not appear to be statistically significant contributors to the model. Overall, the R-squared is pretty decent. And now I can use the link test to check whether or not there's any evidence that the structural equation governing this model, that is a linear equation relating weight, displacement, and foreign to miles per gallon, whether or not it might be misspecified or be lacking some independent variables. So all I have to do is type either estat link test or link test, and then it will execute. So this looks like regression output because it is regression output. So let's talk about what's happened here. The regression is again using miles per gallon as the dependent variable, okay? And we have here hat, which means the predicted values from the prior executed regression model. So we would expect in general that if we have a good model, that these predicted values would be good predictors of miles per gallon. And we see in this case that they actually are not surprisingly excellent at predicting miles per gallon. The key component of the link test is this hat squared value right here, which is just the predicted values squared. And generally speaking, if the model has been properly specified, that is, if we have the right forms of the independent and dependent variables, and if we have the right interaction terms and powers or functions of those independent variables, as well as any possible missing variables from the model are actually in the model, then hat squared should not be a statistically significant contributor to the prediction of miles per gallon. And we see here that it actually is, suggesting that in fact we have some sort of misspecification or omitted variables problem. So here's one example of how you might fix that problem with Stata. If I create a new variable called gallons per mile, that's just the reciprocal of miles per gallon, and then I now regress gallons per mile against those same variables, weight, displacement, and the foreign indicator variable, I get a model that doesn't seem all that different, but now the foreign indicator variable is significant and the R-squared has gone up quite a bit. So maybe this is a better way to work with the concept of miles per gallon by instead working with gallons per mile. So I haven't added any new independent variables, but I've changed the specification of the y variable, the dependent variable. Now when I run the link test, the situation changes. We still don't have a particularly excellent way to predict gallons per mile. That is, our predicted values don't do an excellent job of predicting gallons per mile, but hat squared has gone from being statistically significant to now statistically insignificant. So that suggests that at least in some sense we have less evidence before that we've misspecified the structural equation, or that there are variables that we should add in, or powers of the independent variables, weight, displacement, and foreign, that we might consider adding to the model. Okay? So as always, the thing I want you to keep in mind with both link test and OV test in Stata is that they're just kind of guideposts, that they provide you with a hint as to whether or not you have misspecified the structural equation for your model, or that you might be missing variables. The best argument always is an economic or financial or theoretical argument as to which variables should be added or not added, or what form of those variables should be included. That argument tends to trump the use of link test and OV test. Thanks, and let me know if you have any questions.